Okay, so we are going to be working on solving exponential equations using as logarithms. This comes under 5G of the Cambridge textbook for Methods Unit 3 and 4. So the first thing we need to understand is the relationship between exponents and logs. We've got y is equal to a to the power of x, and that is the same as log base a y equals x. They are so that is something we must understand. So when we are solving, we can do our best to simplify, but sometimes we just need to work on how we can get x by itself. So in this case here, we know 3 to the power of what is 9? Well, 3 to the power of 2. So I can change this straight away to 2 is equal to x log base 3, 5 plus 1. Now we're just going to use simple algebra to get our x by itself. So I'll take 1 away from both sides, and then I'm dividing by log base 3, 5. With this next question where I've got log base e 9, take x log base e is 27 is equal to 1. It's the same thing that applies. I'm just going to take log base e 9 to the other side. As I start to rewrite it, log base e I can write as ln, so ln 9. Then I'm just going to get x by itself by dividing everything by negative log base e is 27. I'll clean this up by changing the signs on top. So this one will be negative and this will be positive just to get rid of the negative on the bottom. I can switch these two around as I'm adding. So it becomes log 9 minus 1 over log is 27. The next thing we need to think about is when we're dealing with log and inequalities, it's the same as what we've already understand. Is when we divide by -1, then the inequality sign is going to switch. Likewise, when we are dividing by a log with an a and a is less than 1, that is the same thing. We will have to switch our sign. There's a couple of forms that we need to make sure that we do understand here. Um, so a to the power of x equals b. We can apply log to both sides, and then that x will go out the front using the power rule. So be mindful that we're able to use that. That is the same thing when we got a to the power of f of x is equal to b. If I apply log on both sides, an equivalent relationship, it will have log a to the power of fx, and that fx will, using power rule, will go out the front. Okay, let's look at a couple of examples. We've got 4 to the power of 2x minus 1 is less than 50. So if I'm going to use my understanding of log, I know that I'm going to have 2x minus 1 left on this side is less than log base 450. The next part is I just need to work my way to get x by itself. So I'll add 1 to both sides and then I divide everything by 2. And I keep this in this form. If you would like to get the exact value as a decimal, you can write it. Over here, I've got 2 to the power of x minus 1 is greater than 0.3. Same thing as we did here. I could do the same, or another way that I could do it is apply logs to both sides. So this way I'll get log 2 to the power of x minus 1 is greater than log 0.3. Straight away from this, I am able to use the power rule to get x minus 1 out the front. Now that's timesing by log 2, so the easiest way is to do the opposite inverse and divide by log 2. That gets me x minus 1, and then I can just add 1. So I didn't need to change my inequality sign, and that's purely because this 2 is greater than 1. 0.4 to the power of x minus 2 is greater than 5. Okay, so with this question of 0.4 to the power of x minus 2 is greater than 5, we are going to use the log relationship. So that means because of our a here is less than 1, the first thing we need to do is when we do the log relationship, our inequality sign is going to change. So that means it'll be x minus 2 is less than, it switches, log base 0.45. The last step that I need to do is just get x by itself, so I'm going to add 2 to both sides. With 0.6 to the power of 2x plus 1 is equal to or less than 4. I'm going to solve this slightly different. I could have solved it the same way. I'm just going to apply log to both sides. So if I apply log to both sides, we've got 2x plus 1. I'll use the power rule to get it out the front. And then to get this bracket here by itself, I'm just going to divide by log 0.6. We said before that if a is less than 1, so between 0 and 1, then I need to switch the sign, so I'm going to switch it over. Finally, I just need to take away 1 from both sides, and then finally to get x by itself, I need to divide everything by 2. So we've got log 4, so x is equal to or greater than log 4 over 2 log 0.6, take away a half.